Oh, hi, Pops. What's the matter?
Mom, let's dance solo pop!
Okay, Pops. Ikaw talaga. Yes, ano ba yan? Hindi ka nakuha.
No, Mom, you're not!
Ikaw talaga kung ano yung pinapagawa mo sa akin. Darla, can you get my phone? Vince, did you know when Mommy was in high school, we experimented with earthworms or uhan? We looked into how they respond to different stimuli.
Really, Mommy? What was it like?
Ito oh.
Imagine living in a world where every little change around you demands an immediate reaction, whether it's escaping a predator, finding food, or seeking shelter from harsh conditions. This is the daily reality for all animals who rely on their amazing ability to detect and respond to environmental changes known as stimuli. A stimulus is any physical or chemical change in the environment or within an organism that triggers a response. Animals show irritability, the capacity to sense these stimuli and react accordingly, allowing them to survive in varying conditions. One common way animals respond is through taxis, a directed movement toward or away from a stimulus such as light, chemicals, or touch. In this video, we will explore how earthworms respond to different stimuli by identifying which parts of the body are most sensitive and predicting the direction of their movements.
Begin the experiment by lining a clean dissecting pan with a damp sheet of paper. This provides a moist environment that simulates the earthworm's natural habitat, ensuring its normal physiological activity throughout the experiment. Subsequently, place an active live earthworm on the paper. Make sure to handle the worm gently. Using a sluggish or injured specimen could yield unreliable or inconsistent behavioral responses to stimuli. Then, apply each stimulus at the anterior end, the posterior end, and the center of the body to identify differences in sensitivity among various sensory receptor locations. Number 1. Contact. Using a dissecting needle, gently touch the anterior, posterior, and central regions of the earthworm's body to assess its tactile response. After 5 minutes, apply repeated stimulation solely to the middle region to test if the worm adapts to continuous stimulation. Number 2. Light. Place a card with a 2mm hole over the earthworm and shine a flashlight through the hole onto different body regions. Observe how the worm responds to light exposure and whether it moves toward or away from the illuminated area. Number 3. Heat. Using a hand lens, focus sunlight on different regions of the earthworm's body. Record any movement towards or away from the heat source to determine the worm's response to temperature changes. Number 4. Moisture. Prepare a clean dissecting pan lined with tissue paper, moistening one half while keeping the other half dry. Randomly place several earthworms across both regions and leave them undisturbed for 1 hour. Afterward, record their positions to determine whether they prepare moist or dry areas. Number 5. Chemical. Dip the tip of a glass rod into xylol or vinegar and carefully bring it close to the worm's anterior, posterior, and central regions without making direct contact. Observe any movement indicating sensitivity to volatile chemical stimuli.
In the experiment conducted, the earthworm's body contracted, a typical response of its nervous system towards the needle that kept poking it. However, after 5 minutes, the earthworm was observed to have no response to the stimulus.
The response of the earthworm with contact is positive, especially when it was poked in the central region of its body and made a contraction. In addition, when it was poked in the anterior and posterior region, the worm's head and tail withdrew away from the source, indicating a negative response. This phenomena occurred due to the axons sending signals to contract as a form of its defense mechanism against potential threats. When the worm stopped from moving, it indicates its adaptation with the stimulus. This adaptation is called habituation, whereas living organisms have a decreased response to stimuli when it is repeated over time. The result theoretically aligned with Broderick and Jaegeli, where they emphasize that different regions of an animal's body, like an earthworm, will exhibit different responses when touched, since they tend to escape contact from outside threats or stimuli.
When light was directed through the 2mm hole of a card, the earthworm immediately moved away from the illuminated area and toward the darker region.
The worm's response implied that there may be a need for it to go towards the dark as a way to survive, because in this way, they will ensure moisture within their body and hide away from predators. As stated by Harper, worms do move away when there is a presence of light. This corresponds to the result that we obtained when doing this experiment. The author also noted that the brightness of the light may also contribute to its behavior. with stronger brightness impacting the worm strongly in a negative way and with weaker light slightly affecting it. Since we utilize a light with strong brightness, the worm's movement was immediately noticed.
In the same manner, the earthworm moved away from the area where the sun's rays were magnified. Throughout the duration of this segment of the experiment, it constantly avoided the warmer region.
The reason behind the worm's response is due to the fact that they are cold-blooded animals, meaning they depend on their environment to regulate their temperature. Thus, since they need to protect themselves from drying out, they eagerly avoid heat. The results agree with Khan et al. In 2010 as they concluded that a high temperature, specifically above 18 degrees Celsius, may be detrimental with the worm's life. Hence, it explained why the worm avoided such conditions and tried to find a colder environment.
When placed at the boundary between the dry and wet regions, it consistently moved toward the area with greater moisture. Despite trying to shift the worm on the other side of the pan, it always favored a moist environment.
According to the University of Pennsylvania, worms breathe through their skin. Therefore, they need a damp environment to allow gas exchange in their body. This mechanism is called hydrotaxis, where living organisms move towards or away from water. This is aligned with Hota and Rao, as they stated that earthworms do prefer a moist environment rather than a dry environment in order to survive. They also highlighted that the worm's resistance to water loss may also contribute to the worm's survivability. This implied that water is crucial to support the worm's growth, especially since they use water to let their cells function.
The earthworm immediately moved away from the source of the odor, showing clear avoidance behavior when it was exposed to the chemicals present in the vinegar.
Worms are sensitive to chemicals because it can damage their body and negatively affect their function. Hence, as a way to survive, they instinctively move away from the threat, or also referred to as the avoidance behavior.
Oh, di ba, Bams? Earthworms either respond positively or negatively to stimuli, huh?
Yes, Mom.
It's an interesting topic how it's called taxis, not the sasakyan, Bams, huh?